I guess one thing to note with our two-tailed test and any testing, just in that previous example, both at the 198 mils and 200 mils that we failed to reject, all right? So in hypothesis testing, just like a court of law, it's a good statement. We cannot conclude that the null hypothesis is true, only that we don't have enough evidence to say that it is false. Okay, so what we aim to do, and even some of my terminology probably in the earlier examples wasn't as precise as it should have been. Whenever we're testing our null hypothesis, we just fail to reject. Okay, we either reject it or fail to reject it. All right, so let's have another look. So again, we've got our two, I guess for our two-tail test, more specifically now that we've spoken about how we're just looking for direction, which means that we've got this magnitude involved now. Typically, we want to know if the distance from the mean is a certain size. Are we 3 points? So if we've got a standard deviation, a mean of 100, 2 points from the mean would be, are we above 102 or less than 98? Yeah, so it's just how many points we are from the mean. All right, so let's have a look. And we're going to have a look at some aptitude tests. Scores for a certain aptitude test are known to be normally distributed with a mean of 30 and a standard deviation of 7. Sounds familiar. A group of 25 students randomly selected to take the test. Find the probability that the mean test score for this group differs by 3 points. So here's one that's clear in terms of that there's no specific direction. All right, it could be 3 above, it could be 3 below. All right, so again, let's work out our key stats. Mu is 30, sigma is 7, n is 25. So mu is 30 and sigma is 7 on root 25, which is 7 on 5. So what we're looking to find is we want to find the size of the difference between the mean, the sample mean, and the population mean is more than 3. All right, so I guess you could argue, if we think this through, x minus mu on sigma, change the color, okay, divide both sides by sigma to keep equality. X minus mu on sigma is z, okay? So really what we're trying to do is just dividing by that 3 by sigma is we're trying to work out how many standard deviations 3 is. So if we're going to say we're going to be 10 points from the mean, well, how many standard deviations is that? So 10 over the standard deviation will tell me how many standard deviations. So sigma itself was 7 on 5. So flip it upside down and multiply, and we get our 15 on 7. So we're 2 and a bit standard deviations away from the mean. That's what we're saying. So the magnitude of z is more than 2 standard deviations away is 2 times the probability that 1, z is greater than 15 on 7, which gives me a total of 0.03. Okay, so the probability of being more than 3 points away from the mean is 0.0321. Okay, so follow that through.